Like off on?
Yes.
Like a complete blackout between?
6 on, 6 on, 6 off.
I've never done it personally. I don't think it would be as effective, really, because you're kind of tricking the coral out. You're shutting it down and then starting it back up again, and it's not a natural process. I mean, cloud cover is one thing, you know, cloud cover, but the UVs and all are still coming through the clouds. I mean, you all know you can still get a sunburn out there if the clouds are out. I mean, if the burn factor is up, you're going to get it whether it's cloudy or not. So I think that would be different. I mean, what the Solaris light, it has the dawn, the dust, the cloud cover, the rainy day. That's different. But an on-off, are you doing that? Are you experimenting?
No, but I've heard about it. Now,
I have heard about it. Has anybody experimented with that one? Is that my water? No, that one is my water. Thanks, Wade. I just don't know about that one. I think it would be detrimental. I mean, I couldn't see it really working because you're shutting the coral down. The zooxanthellae is going to sleep. All the algae, the pH is dropping, everything's dropping, and then bam, a couple hours later you're doing it again when it really hasn't shut down. I don't know. I just don't know. I don't think. Yeah. I think because I mean, natural process. I would hate to be woke up for 2 hours a night and then go back to sleep every night. You know, or vice versa, whatever. Well, I haven't slept anyway. You look at it this way. If there's any blue, that ain't blue. If there's any blue in there, you don't want to read it that way because it's pretty clear. I mean, have any of you guys used this fast test phosphate? Yeah. Some of you have used this one. Salifert phosphate, is that what you're using, the CChem? Salifert? API? I mean, a kit's a kit. You have your preferences like we talked about earlier. Unless you're going to really drop the bomb and get the lab grade, I mean high quality stuff. As long as you can read what you're using, you know, that's cool. Pass that one around if you want. That's clear. But you can see, I think 0.03, that's 0.03, which is hundredths, is coral retardation. So really, any amount of phosphate's bad. So we want to keep that phosphate out. The way we do that, phosphate sponges, granular medias that absorb the sponges. I wouldn't recommend one that leaches what it's absorbed back into the system after it's saturated. Oh yeah. As long as it's in the very bottom, you're good. It's either blue or it's that. I mean, there really isn't, there's not much of it in between with this kit. That's why I like it so much, is because you either have it or you don't. I mean, if there's any in there, you want to get rid of it. You want it out. You want it gone. Calcium. That's the one most people are testing or no. A lot of people testing calcium. That's the big one. Nobody's probably testing mag. I mean nobody's testing mag. I'm going to get you guys testing magnesium. When you get those levels up, you get your calcium in the 400s, get your magnesium in the 13, get your alk 8 to 10, get your pH at least 8.2. If you can't hit 8.3, 8.4, don't worry about it. Leave it 8.2. That's fine. Zero nitrate, zero nitrite, zero ammonia, zero phosphate, salinity. I'm not going to test calcium and all that stuff. It's just time consuming. You guys know, you get the gist of it, but I did want to do the phosphate one because this one's really, it's a good kit. I mean, we use it here. We like it. You were talking about refractometers. It's around here somewhere. I think the guys are using it. Personally, I prefer this one. It's painful, but man, it's accurate. You never have to calibrate it. I'm not going to dip in there. This is a lab grade floating hydrometer. It's a sealed unit, so it never has to be calibrated. It's made in Germany, and we all know Germans are good at reef. They're good at it. They're real good at it. I prefer this one. It's less expensive. It's always on time. There's no There's no way it can deviate. It's a sealed system. Refractometers, don't get me wrong, they're excellent. They're easy to use. Couple drops of water peek through it. However, if that refractive lens gets damaged in any way, if any water gets inside of it, condensation, that's a big one with refractometers. Anything, the salt compounds that build up, and everyone knows salt attracts water. It's gonna attract it. What's it? Flocculant, I think. It attracts water or something. Because like I said, this is painful to use, and it's fragile, but it's always accurate. I think we're about maybe 2.6 in here. Not quite sure. You can't really do this in the aquarium because of the water flow and so forth. Zip tie chamber, Home Depot. If you got an aquarium, you probably got zip ties. These strap ties come in handy. Yep, the increments on this are so finite. You know, for those of us that know about how finite all the parameters, ppm, parts per million, parts per thousand, you know, all these increments are they're so finite. That's why we're testing. And this one should be zeroed out. Got a couple different ones. The swing arm, everybody knows the swing arm, 10 bucks. You won't find one in this store. I won't sell them, I won't recommend them. Don't even bring it here. I'll throw it away for you if you want me to. I'll go ahead and throw it away if you bring it in though. You might get 1 out of 10 that's accurate over time. A swing arm hydrometer. God, I should have got one. I would have. I don't allow them in the store. I'm sorry for those of you that use them. Which, I mean, they're 10 bucks, but they're 10 bucks. That's why they're inaccurate. They're inaccurate. They're inconsistent. Swing arm. Find a picture online. Most of you guys seen this? I can pass it around. Refractometer. Refracts the light through the lens. Reads the specific gravity of the water. It's a density thing. I'm not sure exactly how it works actually. Alright, see, we're reading a little higher on this. This is reading about 2.7. I can pass it around if y'all want to look at it. Just don't drop it. You know, you got one. You ever seen one?
Well, I've seen it. I've never used it.
Which one are you going to look through? You can pass it around. It's cool. Just if you hit the lens, the water might come out. Now that was zeroed out this morning with deionized water, distilled water. Tap water is not going to work. You want to use deionized or distilled. You zero it out. You take the water from your solution, put it on the refractive lens, close over the clear cover, and the light refracts through the water. It's reading 2.7. The same thing, deionized wet, or just a wet rag, you know, just a wet rag, but you can see the pin in there has gotten rusted. Luckily, it hasn't ever collected any condensation in there, so it's off. That has a plus or minus factor, like 0.001, 0.0015. So if you're at 2.6, you really could be 2.7.5, or you could be 2.4.5. So that plus or minus factor with salinity, to me, is a big deal. And it says it right on there. Some of them have larger plus or minus factors.
Temperature affect your refractometer?
Yes. Temperature, they are temperature sensitive. With a few drops, it's quick. But if it's really cold water and you put it on there, you can actually watch it move. You'll be able to see it move. Or if it's real warm, it takes it a minute to...
There are also auto temperature calibration refractometers as well that work between, I think it's like 72 and 80.
Now, yeah, exactly. There is a temperature. Some of them are self-regulating. Some of them have lights. They get real fancy. They get real expensive. But I would say, ultimately, they have a plus or minus factor of 0.002. Maximum. Maximum on this is 0.001. That's max. So, really, you might have a 0.008, which is, when you're going parts per thousand, my preference, obviously. I think you guys got that part. I'll sell you either one. 35 bucks, 80 bucks. Painful, easy, larger deviation, smaller deviation. They're both good though. We'll use this to calibrate that as well as deionized water. This one's been zeroed out.